So just to be clear, you've seen that before, right? And that's on the previous page that you were looking at. You've seen those before. And that's on the previous page that we were looking at. You know the law of sines. We're not going to use that during this unit. You know the law of cosines. We're not going to use that during this unit. And you know the area of a triangle, but we really don't need it. Yesterday we glanced at even and odd identities. Today, this is where we live. Okay, so what's going to be really important is that when you get to your test, that you're going to know how to navigate this sheet and know what to look for. So we have to understand the purpose of sum and difference formulas and be able to find them. Okay. Way too much confusion about writing Greek letters 4th hour, so I'll just write capital A and capital B so that there won't be any upset feelings. So we'll just do that. So if we flip back to our notes, we have these sum and difference formulas, and they go like this. The sine of an angle A plus another angle B. And what it happens to be equal to is the sine of angle A times the cosine of angle B. Plus the cosine of angle A times the sine of angle B. Now, if instead of addition it was subtraction up there, then it would be subtraction down here. And that's our formula. You don't really know why we're using it right now. You will by the time we get to the end of our notes. We'll complete the front side today, and that will be our deal. Please let me show you what you should not do. You will be awarded no points on the test for doing this, but it happens generally about at least a half dozen times when I have this test. If you had the sine of 30 plus 60, some people will simply distribute the sine and get the sine of 30 plus the sine of 60. Sine of 30 is 1/2. The sine of 60 is the root of 3 over 2, and they get 1 plus the root of 3 over 2. Okay? Here's the deal. If you take 1 and add it to the root of 3 and divide by 2, you get a value bigger than 1. And you guys all know that sine has to be between 1 and -1. In fact, sine of 30 plus 60 is the same as the sine of 90, which is 1. Please do not ever make this step. I will say it probably 4 more times during this unit to try to rid that from your brains from wanting to do it. That is totally illegal. You can't do it. I think it's natural, if you have x times, say, 3 plus, y, that people would say, you got 3x plus xy. I think that that's kind of what people go for during that time. But we can't do that. You rely on what's put in front of you, which is that. Question. Oh, no, I did not say that. I said I'll continue to repeat. If you would like to see why this formula comes out to be that, it's about a 20-minute ordeal to kind of show the proof of why that works. Simply just reference section 7.2 in your book. Unfortunately, we don't have time to derive all the formulas. Normally, I derive all the formulas for you, like law of sines, law of cosines. We just don't have enough time with the rest of the formulas we have left. You have to know this. When you see sine of two things added together, you need to say, oh, that's a sum and difference formula. I need to go there. You don't have to memorize the formula. You get all this on the test. But you need to go to the red box. Your brain needs to signal, hey, go to my sheet, look for some formulas. Look for something that looks like that. That's what needs to happen for you. And most of the time it does. Most of the time it does. We have another one in terms of cosine. The cosine of, say, angle A plus angle B. And what that one comes out to be is the cosine of angle A times the cosine of angle B. And then instead of plus, it switches to minus. Minus the sine of angle A times the sine of angle B. If in the beginning, instead of A plus B, it was A minus B, then down here it would switch to plus. So you've probably seen a plus minus sign before. This might be the first time in your mathematical career you've seen a minus plus. That means it switches from what it was. Tell me what is similar about the sum and difference formulas for sine and cosine, and tell me what is different about them. What's similar? They both use sine and cosine. They're in pairs. You have a pair here, pair there. What's different? You have cosines here, paired, by here, sine and cosine. So here they're the same, here they're different. Okay, that's what you need to recognize. The flip in the sine is also different. Okay, whereas the sine is the same here. So, okay. So let's put them to work. These are 4 of the most basic examples of how this formula gets used. We could really stretch this out and look at how these formulas are used much more in depth. We're not going to do that. We are giving you the most basic and simple examples, and that's what I'll continue to do for this test. I'm not trying to push us down a path that we will never tread. Yeah. I will show you. Some people were angry I didn't put the degree symbol there. Must have just been a bad day of writing notes, sorry. Find the exact value of the following. Sine of 23 degrees times a cosine of 67 plus cosine 23 times the sine of 67. The key phrase in these directions are exact value. Exact value. Some people will turn to their calculator and they'll type that in. And they'll spit out then a number. Okay? Something like that. I award you no points. I can teach Kira to plug that into a calculator. I cannot teach her how to use the sum and difference formula. That's the trigonometry. So your work must support your answer correctly in order to get these points. Does that look familiar to you? Yes. Where does it come from? This, when you see this, it should, be in your brain right now. Hey, I see that here. That's similar. In fact, that looks like sine of some angle A times the cosine of some angle B plus cosine of angle A times the sine of angle B. That's what that looks like. And we know that that formula right there is the same as sine of what? A plus B. So all I need to do to simplify this is to figure out what A is and what B is. What is A in that problem? It's 23. What is B? Do you know what 23 plus 67 is? What is it? That's the sine of 90. So the sine of 23 times the cosine of 67 plus the cosine of 23 times the sine of 67 does happen to be the sine of 90 degrees. Do you have an exact value for the sine of 90 degrees? It is 1. Question. Sometimes when you plug into your calculator will round. I just made up 0.99. Your calculator would probably give you exactly 1, possibly, maybe not. I don't know, depending on how much it rounds. This shows that you know how to use the formula. The other way shows me that you know how to use the calculator. Yes. So right now, this piece right here, you're not going to encounter many times where you use that. This is kind of like one of those practice pieces of, can you recognize the shape and form? And if you can, then maybe you can do the more challenging problem. And once you can do this one, then we have other stuff that we can build off of as well. So, but you're absolutely right. Not too often when people sit down and do all that work as opposed to type in the calculator. However, like I said, if we can't see this, we're probably not going to see this. Okay, so where did I get 1? That's where we're at. If you look at your unit circle sheet, which is the other side, if you notice, this is really important. Sine is y over r, and cosine is x over r. So in the unit circle, sine is going to be your y values, whereas cosine is going to be your x values. And so if you look at 90 degrees places you right there. Sine is the y value, which is 1. It would be great for you to have this, say the x and y values, the pattern up here. You'll move through this stuff a lot more quickly, okay? However, if you can't do that, you can either look at the x and y values, or what you can do is simply go over here. So 90 degrees is the same as pi over 2 radians, and the sine of that is equal to 1. So I have that chart for you. Okay, that's what you got. So this is how you navigate if you can't remember it. And if you can't remember it, that's fine. It just might take you a little bit longer. Okay, so here we go. We try another one. We have the cosine of 2 pi over 3, cosine of 5 pi over 12, plus sine of 2 pi over 3 times the sine of 5 pi over 12. Let us do it. What does this look like? Cosine. Same difference for cosine because it's got the two cosines together. So this looks like the cosine of some angle times the cosine of another angle, plus the sine of angle A times the sine of angle B. Now, if I can write it in that form, I know that's equal to the cosine of what? A minus B. For cosine, it's opposite, we said. It switches. Okay? So all I have to figure out is what A and B are. Cosine of what is A? 2 pi over 3 minus 5 pi over 12. If I subtract those, I need to find common denominators. So this happens to be cosine of 8 pi over 12 minus 5 pi over 12. What's 8 pi over 12 minus 5 pi over 12? Pi over 4. 3 pi over 12, which is pi over 4. So you look at your sheet if you don't remember, and the cosine of pi over 4 exactly is 32 over 2. Okay, pi over 4 and 45 are related to one another. One is a degree measurement, one is a radian. But the sine of 45 is not pi over 4, just like the cosine of 45 is not pi over 4, just like the tangent of 45 is not pi over 4. That's simply which one are we working in. Okay, so these are the values over here that you choose. We're not converting at this time. Okay. Okay. How about this? That's 45 degrees, right? That's also pi over 4. Same angle measurement. Either way, the sine is equal to root of 2 over 2, and the cosine is equal to root of 2 over 2. Okay. All right. Let's apply it now. So now we're going to use it in the kind of the opposite way. We've recognized the shape of the formula. We've made it work out. But now we want to find these exact values. Sine of 15 degrees. On your sheet, do you see 15 degrees is an exact value that you can calculate? As I look at it right here, I find 15 degrees. I got 30, but I don't have 15. People might want to just divide it by 2, huh? Can't do that. Okay? Can't do that. So here's what we do instead. And this is the key. I don't know the exact value of sine of 15. It's nowhere on my chart. But there's 2 angles I do know the exact value of that I can either add or subtract and get 15. What are 2 angles whose exact sine value you know that you can either add to 15 or subtract to 15? 45 and 30. So this is the same as the sine of 45 degrees minus 30 degrees. You could also use the sine of 145 degrees, or 135 degrees, minus 120 degrees. You could also use the sine of 150 degrees minus 135 degrees. You can use any combination that will give you 15. It doesn't matter. You're going to come up with the same answer. It's entirely up to you. I'm going to use 45 and 30 because I think that's what people would choose. Some people chose 60 and 45. That's fine. Either way, you're going to come up with the same answer. So, here we go. I can write this as the sine of 45 degrees times what? Cosine of 30 degrees. Minus or plus? Minus cosine of 45 times sine of 30. Now I need to figure out those 4. I've got those 4. They're right here on my sheet. So list them. Sine of 45 is root 2 over 2. Very good. Cosine of 30 is root 3 over 2. Cosine of 45 and sine of 30. 1 over 2. So now I just simplify. What's the root of 2 times the root of 3? Over 4 minus do they have common denominators? Can you simplify the root of 6 or the root of 2? No. That's my exact answer. So that's the exact value of the sine of 15 degrees. Inevitably, I will have people who will take sine of 15 on their calculator, they'll get, say, 0.2345. But that's not the exact value. That might be the exact value within 1/10,000, but that's not the exact value. That's the exact value. No points. Full points. Last one. Cosine is 7 pi over 12. How is this one different? I'm in radians. So most people at this time will say, I don't want to work in radians, Mr. Gens. I want to convert it to degrees. So that's fine. How do you convert to degrees? You multiply by 180 over pi, and you see that what happens? Pi's cancel. 180 over 12 is 15 times 7 is 105. This becomes the cosine of 105 degrees. Very good. So Holly decides that she wants to pick two angles that add to 105. You could pick two angles that subtract to 105. Depends on how you want to handle the situation. So she picks two that add. So we will do that. We'll pick the cosine of 60 plus 45. She now writes it in expanded form. Cosine of 60 degrees times a cosine of 45 degrees. Then minus sine of 60, sine of 45. Ask the question. You get that on test. But I will say, if you, so again, it does follow a nice pattern, doesn't it? As you kind of go around, 1, root of 3 over 2, root of 2 over 2, 1/2, 0. And if you follow it the other way, 1, root of 3 over 2, root of 2 over 2, and 1/2, and 0. You can see, and it continues to repeat itself. So it follows a great pattern. There's only 1, 2, 3, 4. There's only 5 numbers to remember, and then they're different by a positive or negative. So it is completely possible to remember them. If you can't, then yes, you have to turn to that. It's the only way to go about it. Is it cheating to tattoo it on your arm? Yes. Okay, cosine of 60 degrees. 1/2. Cosine 45. Root 2 over 2. Minus root of 3 over 2 times sine of 45 is the root of 2 over 2. I multiply root of 2 over 4 minus root of 6 over 4. That's what we get. Yes. Yes, almost always you will come up with root of 2, root of 6. Yep. So, you see the pattern. Over 4. Yes. You could have. You sure could, yeah. Yep. I just try to choose what people like. There's your assignment. You got 20 minutes. You know the Pythagorean theorem? Square root both sides. So the distance formula happens to be So, and Taylor, your question earlier before I get to Cole's, okay? This is your assignment, guys. But so it's about remembering those values. This is really where it comes into play. Is next year we're evaluating this. Whoop. Now here's the problem, okay? When we do that, that's not very difficult, okay? It's not a very difficult problem. You'll be very good at doing this next year, but what it does require you to do is this. You have to know what the cosine of pi over 3 is, and you have to know what the cosine of pi over 4 is. And I can give you a sheet that has those values. However, on the AP Calculus exam, if we were a school that tried to prepare everybody in calculus to take the AP Calculus exam, you guys all get the college credit, right? But if we were doing the AP Calculus exam, you wouldn't be given those. So I would be making you guys memorize those. And if you couldn't memorize them, what you would have to do on the AP Calculus test then, in order to come up with those values, is you would have to draw pi over 3 is a 60-degree triangle. This is 30. This is 90. This is 1. This is 1/2. This is the root of 3 over 2. And since I'm looking for cosine, I'm looking for the x value, so it's 1/2. And you know, it's that process that becomes difficult. So that's the feedback I get from people that go on to college. They're like, I wish I would have remembered all those values, because now my professor just assumes that we remember them all. You know what I mean? And so I don't know what to do. It's like, okay, do I give you guys a sheet, or do I say, nope, got to draw it every time? You know what I mean? I just figure I'll give it to you, and then when you need to actually do it on your own, then you're going to start drawing it. So that's the reasoning behind it. So, yes, Caitlin. No stupid questions. For right here? Okay, so all right. Let me see if I can answer this question. And if I say something stupid, tell me there's no stupid answers then, okay? All right? How's that? I had to choose 60 plus 45 because 60 minus 45 would give me 15. And I want to know what the cosine of 105 is. Right here? Well, this sign right here, in the formula, this says plus minus, and this says minus plus. So if I use a plus up there, I have to use a minus down here. Yeah, so when this was plus here, that was my indication I have to switch it, make it minus there. For sine, it stays the same. Does that make sense now? A lot of people had questions actually passed through. You guys didn't ask it. They're like, why is it 60 plus 45 and not 60 minus 45? And the idea is it has to add 105, and 60 minus 45 does not. So, but you guys didn't have that question. So, does that make sense? Cool? All right, I'm on my way. Goodbye, YouTube name.